class itself. You can look at the constructor list and you can see everything which is going to be used in the class. And that's good because sometimes the worst thing about a global variable is the fact that its use is hidden someplace deep inside the class. And parameterizing the constructor gives us the explicitness for this. And this also tends to fall in line with what we are seeing with dependency injection and various other techniques we're dealing with code. So we have these three different techniques. I just want to go and show you that one. Does anybody feel bad that we are not testing the right class here? Yeah, this is a funny thing because often people look at this and you're like, how can you say that this is a test for our stuff because we're not even testing the right class? But the important thing to recognize about this is that we are never testing classes. This is the truth. We never test a class. What we do is we test a path of execution inside of code. And if we can look at the code and convince ourselves that we are executing the path that we care about here, even if we are replacing one piece of behavior, then we can have a valid test for add event, even though we have subclassed scheduler and chosen to override some of its pieces. And that's just something which is true, and something to get used to. Okay, so we have this. Let's see what other kinds of testing problems we might have in here. Can anybody imagine any reason why this might be hard to test? This function. Huh?
Just test this.
Too complex?
There's the setting map. You can a follow.
Yeah. Well, first of all, I agree with you. This is quite a bit of logic here. But no, I agree also with this. This is static. But I don't know, is there anything wrong with static methods? Yeah, you can't really override these things, right? Cannot be replaced. Yeah. And do all static methods have to be replaced? No. I mean, if you think about something like math.tangent or math.cosine or something like that, those are static methods we would never want to replace. The place where it's a problem is when we have a static method that hides something we don't want to go and replace. And in this case, that's happening because this holiday is basically going and accessing a database behind our code. So we're accessing a database, and so what can we do about this? Well, let's take a look at the code first, inside of here. We look inside of, this is actually a class called time services. Okay, so he says, imagine this method has a real implementation. But anyway, these methods here, have you ever seen classes like this which have nothing but static methods? Yeah. So there's an old name for this. They used to call these utility classes. Why do we have classes like this? Sometimes people do this to interface with another system. They create a class which just has delegating methods to some other system. Sometimes people create classes of static methods because they don't know where the methods belong. And this becomes kind of like a graveyard for things that they don't know where to put. Okay, that happens sometimes. So anyway, in this case, one thing we can do is this. We could look at this and say, there could be a real abstraction here in the sense that we could make this a real class, a class that has virtual methods, replaceable methods. So what we could do is we could start like this. And we could say public boolean and make a new function. Call it isDate aHoliday. It has a slightly different name. And the thing is, it's actually going to go and delegate over to the static method. Does that help us at all? If you can, well, what we can do is we can do something like this. When we go back to our scheduler, we could say, look, right here, if we had an instance, I can call it services, we could call a function called isDate aHoliday and get the same effect. Right? So if we have that, how do we actually get a services instance into this method? We just create it. Okay, so we do this. Let's go ahead and say we have time services. services is equal to new time services. Now, does that allow us to test? No, it doesn't. Okay, so in essence, the problem here is something that you would talk about replaceability, but there's some terminology I use for this. I often call, certain things a seam, kind of like a place where two things connect. When we have a method, there's a seam when we make a call to the method, if it is a virtual call, right? That seam is there, it allows us to replace. When it's static, we don't have the ability to replace it. But the thing is that for every seam, for every way to replace something, there has to be a point at which you enable the change that you're going to go and use to replace things. So right here, we have a seam here, but we don't really have a place to change things because this thing is being created inside of this class. What we can do is we can pass this thing through the constructor, right? If we pass it through the constructor, then we have an enabling point where we can replace things under test. There is another option, though. People don't think about this very often, but sometimes it's useful. What we can do is we can go ahead and replace it over here. You just do pretty much the same thing as parameterizing the constructor. We have this. We're just going to set this one up so it goes and delegates over. So once we return, get meeting, page slot, new time services. Okay, so this is the one with the signature that everybody has used. And it delegates over to this one, which we can basically go ahead and run a test with. Now, this is, weird. This is one of those things where you probably aren't going to use this sort of technique all that often. But it is something which does come in handy in some odd situations where you have a very, very big class and you're not ready to pull this thing up into the constructor as an additional parameter in order to unbreak the dependency. So we can do this sort of thing. Sometimes people will do this. They basically make this into like testable get meeting. Okay, so that it's obvious that this is the thing that we are able to test. We can use the annotation of some sort if you have it in your language. But this is, yet again, another way of going and imposing a seam in order to go and break dependencies. It isn't so important in Java. Sometimes in really bad C++ projects, people do this sort of thing to go and deal with substitution for various items. But the thing I'm doing is basically showing you possibilities for this sort of thing. Could we have done this without going and introducing the instance here? Well, we could have done something a little bit different. We could have had some way here to go and basically replace things just like what we were doing before in the singleton, right? We actually have like a singleton, like an implementation method we use here. And then basically change all of these methods so that what they do is they delegate over to the implementation. Say, return impl is passed to, and do that sort of thing. You can basically do that for each one of these things. If you do this, then the advantage is that nobody has to go change their code. You can just go ahead and keep on using the static methods. It's just that you're able to go and replace what's being called below the static methods. Is this a good thing to do? Yeah, why not? There's a possibility that there will be multiple calls to set testing instances. Different things. But the thing that's interesting here is that we do have a mocking point. So if we have like an impl, and we set this to like say new impl, we just go ahead and type in the code so we are on the common base point of reference. We have private static time services instance. Impl is equal to new, time services impl. Okay, so we have that, and this is going to be a static. static, what we could do is we can basically substitute in any kind of a mock that we want to here. And it could basically say, okay, well, the first time it's called, it's going to return this, the second time it's going to return this, and that sort of thing. And use a mocking framework to work against it. So yeah, we can do that sort of thing. We can replace as many things as we want to in the test that we have. But there is a reason I don't like this as much as the other technique. The reason I don't like this is that, again, this keeps our code from becoming more explicit, right? More having the stuff be apparent to everybody who's reading it. In essence, back in the code, we still have places where we're calling the static method and it's just really this hidden dependency. Whereas it's really something that's rather important. It's accessing a database. So I prefer to move towards this sort of thing, where what we're doing is we're basically creating these instance methods. And yes, we do have to change the calling code in order to be able to call these things off of an instance. But at least someplace in our class, we are showing that we are passing in something from the outside world. That thing that we are passing in is something which is important. It's not just a call that's hidden deep down globally inside of the system. So that makes things a bit more explicit. There are times when this is useful, though, to go and replace the implementation behind a set of statics. The times when this is useful are places where you want to go and start to generate tests which are larger than just unit tests. One of the things that is kind of awkward in systems with global variables is that when you try to remove them, often you find that you have to go and pass them from place to place to place to place. Have you ever done this? Try to remove a global variable and you have to pass it as the list all we have, right? So this is a terrible thing that happens. And if you're trying to go and get tests in place around some big piece of code, it may be a lot of work to go and say, look, here's something where a piece is being used, here's where it's being declared, it's global, here's the top of my system, my test entry point, I need to pass it here, 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 all the way down to here. And you can do an awful lot of work in it. And some code bases are so big that it just takes forever to do that. So this technique of going and replacing things behind the static can be useful when you want to go and do higher level testing, like say through FIT or some other testing framework where you're going to be testing things that are basically many, many calls deep in some area of your system. But in general, it is better to make things explicit. Why is this a problem? I mean, why does it get this painful in your code to go and pass things all these different levels? Is this just a natural thing in systems that if you have global variables and you choose to get rid of them, that you'll have to pass them down many different levels? Yeah, it's a funny thing about this. I mean, people have said for years and years that global variables are bad, right? I mean, your professors told you global variables are bad, right? Do you have global variables in your code? You probably do, right? Most people do. The thing that's funny about this, though, is that there is something very interesting about the use of global variables that it took me a while to realize. And that is that you change your design substantially for the better when you do not have global variables. And it's not just that thing of, well, now it's easy to see that nothing bad is happening way down in the deep part of the system. You actually change the structure of your design when you do not have globals. To give you an example of this, I worked on a system a long time ago. It was a library, one of the first systems I worked on when I was out of school. And I worked for a man who had some very interesting ideas, very strict ideas about things. We were creating this big system in C++, and we wanted to be able to run the same thing in multiple threads in the same process. And we wanted to make sure there was going to be no interference between the pieces, multiple instances of the same thing. So what this meant for us is we wanted to have no global mutable data in the system at all. We wanted to basically set things up so that anything that could be changed by this part of the system was passed into it. So when you think about things that are global and mutable, one of the things that is global and mutable in a system is the heap, right? Heap is global and mutable. Basically the dynamic memory store. So this is the early days of C++. We didn't even want to use new and delete. So what we did is we basically introduced a class called memory. And it basically had two methods on it, allocate and free. Nice methods. And we looked further. There were other things that were global and beautiful, we thought. So one of them was basically going and dealing with errors. Okay? So we didn't want to use exceptions. This is the early days of C++. So we decided to create some abstraction, like an error recorder. And you go to the error recorder and you record errors. And I thought, okay, this is interesting. We're going to have to pass references to these two things all the way through our code. Right? It seems like we would have to if they are going to be global. And I thought, this is terrible. I mean, who wants to pass references from one place all the way down the code? And there's a word for this in old structured programming. It's something called tramp data. It's kind of like data. You know what tramp is? It's kind of like a person with no money, and they go from place to place. So this data is passed down from place to place. And nobody would really want to do this. So I thought, let's make things easier. I created some universal base class. It's called base object here. And basically, base object held on to a reference to error handler, error recorder, and memory. And I looked at this and I thought, this is interesting. Every class that we have in our system is going to have to inherit from this one base class, just so we can have a reference to error, recorder, and memory. And I thought, this is really not a very good design. It's just it seems like a very strange thing to have here. And particularly in C++, in the early days, there was a strong bias against having a universal base class that everybody would use. So we started doing this, and the thing that was interesting is that after a couple of years, maybe 3 years or so, I looked back at this system, and something very interesting had happened. If you look at all the classes of the system, there were only about 1/3 of the classes that inherited from this base class. The other 2/3 of the classes didn't. Those 2/3 of classes did not need to use error reporting or memory. This is kind of strange when you think about it. These are two things which are considered to be usually universal concerns. But still, in this system, you discover that there are some places where you need these things, and other places where you don't. And it was obvious in the class structure that anything that came below this was something which needed those things, and the other things didn't. So this is a funny thing about global variables, is that whenever we make something global, we basically assume that it will be used every place. Right? It's global, so it's easy to access every place. And in a system, if something is easy to access any place, people will access it any place. Right? But the truth is, if you have a system and there's something that's being accessed in every single class in your system, what that really means is that there are really no layers in your system at all. And that's really bad architecturally. So we can expect that for just about any resource that you use, some things will use it and other things will not use it. And with that knowledge, it allows us to basically see that choosing to go and make things not global will actually affect our design in an interesting and good way. It allows us to document in our design where things are being used. So as a very simple example, imagine often databases are used in applications and you have some global access point to a database. But suppose, for instance, that you say, look, we're going to go and pass our access to the database around in the system. And you find this is rather strange abstraction. And you think, okay, well, let's go ahead and have some kind of base transaction class. And you say, look, let's go ahead and have our transaction hold on to our database provider, or database reference provider. And then you can look in your design and you can see that everything that is a transaction, okay, can have access to the database. But there are many other things in the system that simply will never get a reference to the database. And for that reason, can never actually use it. And that forces you to separate in your design the things which access it from the things that don't. And again, your design becomes much more explicit. It goes and tells you more about what's going on in the system. And this is actually a substantially different system that you would have than if you were able to just access the database any place within your code. If you can access it any place in your code, you probably will. And this is how we get back to this whole issue of why it's hard to go and get rid of singletons in systems, to get rid of this sort of thing. It's because we let it happen. And so it's good to try to avoid this sort of thing. But the fact of the matter is that when we are working in an existing system, we don't really have the choice of going and saying, I wish I could write it completely over again. We do have to deal with it the way it is. And because we have to deal with it the way it is, we have to go and figure out which technique is most appropriate for us going forward. So for this right here, we could either go ahead and place something behind the scenes that we replace, or we can do the other thing, which is just simply to go and do this right here, which is introduce this one delegator. And over time, what we hope will happen is that we will add more of these delegators into this class and get to the point where what we can do is change all of our code so that it uses the delegators rather than using the static methods. And once that happens, we can take the code in the static methods, put them in the delegators, and get rid of all the static methods. And we have incrementally over time make the design a bit better. It's a little bit more explicit that we're basically using this particular thing. So, I don't know, this was just trying to give you a flavor of this kind of work with large existing legacy code bases. A very important thing about doing this is that you have to kind of, it's great to love clean code. I love having very clean code and everything, but sometimes you have to do some of these things, breaking dependencies in some strange ways in order to go and get yourself to the point where you can easily write tests. And so it's kind of like having, you're doing something which isn't, all that aesthetic isn't all that great, but it allows you to make things better. It's very much like if you were, say you have a terrible pain in your stomach and you go to your doctor, and your doctor says, oh, you have appendicitis. It's a very serious thing. We have to give you surgery and take your appendix out. And you say to the doctor, yes, you can do that, but just don't leave a scar. Okay? I mean, that's a very silly thing to say to a doctor who's responsible, to give you good opinions about what to do. But the thing is, we do leave a scar sometimes in the code, a place, a cut, an incision. But when we do this, we allow everything underneath it to get better. And ultimately, that is the goal of our code, is to be able to slowly make things better over time. Another thing to mention, too, is how we think about encapsulation now when the industry is changing a little bit. We talked here about going and adding extra parameters to constructors. 10 years ago, if you told people you were going to pass in all your dependencies as constructor parameters, they would laugh at you and say this is bad design because it violates encapsulation. Is that true? It does violate encapsulation in a sense, but let's ask, what is important about encapsulation? What does encapsulation do for you?
Hiding implementation.
Hiding implementation. Is it because we're scared of implementation that we want to hide it? Sometimes. Okay, but no, encapsulation, it's interesting because you can look at it, there are many different reasons for encapsulation, but the key thing about encapsulation to me is I can look at a piece of code and understand it because I know that nothing outside is going to affect this, and this isn't going to affect anything outside. So it's a tool for understanding. This is what encapsulation is. Now, the interesting thing, though, is that writing tests for a class is another way of getting understanding. When you write these tests, you can actually show exactly what is working right now. And that can basically serve as a document and see how all this works. And you achieve the same thing just by going and having a slight variation. So I think that we do evaluate encapsulation sometimes to make things more testable, but we do end up with something which is better, in my opinion. So, any questions about this? Or comments?
Michael?
Yes.
I understand there can be problems in the testing schedule when schedule will be changed.
Yes, that's a possibility. if the scheduler is changed, then we might be hiding something accidentally within the testing, the scheduler test. And that's, this is a technique that I don't really like to use all that often, but sometimes I will do it pretty much because we are dealing with a very big class and we have to start to extract certain dependencies in order to get past things. But you're right, there is a bit of a maintenance issue with this because the testing scheduler and the scheduler are going to have to maintain synchronization over time with this. So, some of this also has to do with how confident you feel in changing some of the code. If it's very complicated, you may want to be far more conservative about how you write tests and you do some of these things. In other cases, you feel like, yes, I won't be able to know if I load this thing. So let me do something which is nicer, like parameterizing the constructor, for instance. But you're right, there is that dependency. There's another thing about this too that is awkward, and that is the protected. If we look at send, you made this method protected so that we could go and overwrite it in the subclass. But sometimes people will look at this and they will think, oh, okay, this means that in production code we are subclassing the scheduler. But our intention is never really to subclass the scheduler, we're just doing this for testing. If we have our test cases in the same package, we could go ahead and just make it, package file. But still, it is a little bit strange that way.
It's also correct for constructor.
Sorry?
This is also correct for constructor where you specify.
It's also correct for the constructor.
Where you specify display.
Yeah. What? You're talking about up here in the header?
Yes.
What about this?
You say that when people say, looking at the protected windows, they say that it can be overridden with implementation.
Yeah.
The same thing can be with display, display as argument, and say, oh, that can change.
Yeah, so this happens, and sometimes what you can do is you can use an annotation for saying we're using this for testing, or just a comment to say we're using this for testing. A funny thing that happens with this too is that it really depends on what your orientation is to your code. Sometimes people look at things and they say we want to document very much that this is the constructor that people use in production. And it would not be a big design, and it's a big design problem if we don't use this constructor. In other cases, you're kind of like, okay, well I do this, and if somebody needs to go and create a scheduler and supply their own display in production code, I don't care. It's okay with me, because I'm not trying to go and communicate that this is the only way we create schedulers. And this is a funny thing that in some code bases, you may have very strong opinions about how people should use the class, and you may have a good reason to enforce that opinion. In others, you're kind of like, well, we are all a team, and I trust the other members of my team not to call this in a production situation unless they really needed to, unless there was a reason to go and deal with that. So yes, it's a matter of balancing how you communicate in the code versus how you communicate with the team. It's that issue. When to not write tests? When do I not write unit tests? Sometimes when I'm prototyping things. I mean, are you trying to like figure change? Yeah. No, not always. I mean, sometimes you have some small change to code, and it looks like going and getting the tests in place would be very, very difficult to do. And you have to, this is a real world situation. You have to lay out how much it costs to go and get a big area, or a very difficult area of code, a code in the test right now, versus how much time you have to do to deal with this sort of thing. And I say this very realistically because I do visit teams that have really, really horrible code bases, and if you stop right now and said, look, we're going to write a test for every single change that we do, it would grind everything to a halt in the team. The ideal thing is, yes, write a test for every little change that you make, because in the process you make it easier to do that over time. But realistically, sometimes that is kind of awkward to do. But if you weren't doing this, you would be making changes to code as it stands. I think the very important thing for us to get as developers is that testing is a tool for us Okay? And we should write as many tests as we feel is necessary in order to convince ourselves that we have done the right thing. And so it's a great tool for us that way. So we just need to pay attention to that. If you are conscientious about this, you discover over time that you are writing more tests because you want to know. This might be really working. This is a great way to not only know that now, but to always know that in the future.
Michael,
Yeah.
we have a situation that the email service where we send the email to the specified address, and how we will, in this case, test that the address is correct. For example, if somebody changes the address and the recipient previous has empty.
So yeah, for this to be easy enough, we can just go ahead and intercept that by going and replacing the implementation. You know, in this case here, you know, we could go and mock it out in the in here. We can basically go ahead and just, you know, it's funny. Mock frameworks are great for going to test-driven development. You know, from the very beginning. Often when I'm working with existing code bases, I will hand code some mocks because it's just so simple to do. In this case here, we can just go ahead and save the address, make it a public variable here, and just go ahead and test it within our test to see if we are getting the one we want to get. But yeah, you can use mocking frameworks for this sort of thing also. So save that and use it.
Michael, what is the latest support deciding to move to the configuration?
Move what configuration? Like the address and all that?
For example, like others, when you decide that it should be moved to configuration or not?
Yeah, no, usually if you have some strong need to do this for like some internationalization or something like this, it's good. Yeah, I mean, duplication is often a good guide to tell you whether you have something, if you have something which is being called out literally in two places, you introduce a constant for it. For me, it just seems to be, if you notice that you have this class of information that you may want to go and replace in a different way, and you have a concrete need to actually replace it in a different way, you factor it out to a separate class, and the class could be, you know, save off the configuration file or not. The idea of actually using a file for configuration is something which I think you need to have a realistic need to do it. And often that is because somebody other than the programmer needs to go and make those changes. I'm not a big fan of going and introducing configuration files unless you really need to. I think what's nice is that even if you have constants in here and you put them into a separate class, you know, you can refactor that easily within the tools and see that sort of thing and make those changes. And that's good. I don't know if anyone's seen this, but sometimes you can get applications that are over-configured. Can we get this at all? It's, sorry?
I use GMX for
GMX? Yeah. So it's nice to get into a situation where it's like, well, what do I test? Because I have all these buttons to change, right? So this sort of crazy. Yeah.
Like there's an example of the system in which you start to function this way, evolutionary, and you get to brilliant design or something.
Oh, using this to get to the brilliant
Maybe not brilliant design. I see over time, maybe 1 year, 2 years, or something that you.
You know, the thing is, working with this, you don't really. Here's what happens with this. This stuff is kind of conservative and it works in the context of existing class design. So, right, you have an existing class design and you want to make changes to individual classes. So you break dependencies in order to go and make things a little bit better. But you aren't in the process of doing this going in, making big changes to your class design. What you can do though is if you can start to, I think that's the way to say this. We're working with this one class here called schedule, and we're writing custom schedule, and that's good. But the custom writer scheduler are going to allow us to refactor scheduler and everything that's underneath it, right? So scheduler basically acts as a class which holds on to many different things. The tests that we write will allow us to, over time, have the confidence to go and basically change class structure and everything else underneath there in a good way. And sometimes that happens. But for the most part, if we are just trying to go and add features into the code base, and trying to refactor various things, we may end up just keeping a lot of the same class structure over time, pretty much the same. We're just trying to go and add in features in good ways. Often it's a conscious decision to go to a class and add lots of tests so you can refactor underneath it. But the thing is, you do this, but then all the other classes, they kind of remain the same also, right? So with this, it's like you can move towards bigger scale refactorings, but the thing which happens often in large existing code bases is you aren't really going to go in there and change completely re-architect, the structure of everything. And maybe 2 years from now, it's going to look roughly the same. It's just that some areas of the code will be a lot easier to work in because you have tests, right? It seems like there's this thing, imagine that you have a tree, right? And you go up to this tree when it's a small tree, and you kick like this and bend sideways, right? So the tree bends sideways. Is it ever going to grow up perfectly straight? It's kind of like you've already done a little bit of damage to it in a way. And it's like everything that you have that grows, its growth is based upon its initial conditions. So you have in a code base some initial conditions that created the structure that you have. And it's really hard to go and basically get rid of all those initial conditions unless you rewrite them. Now, in practice, what happens often is that you can get areas to be a bit better. You can make changes easier in different areas of the code. And sometimes people get so frustrated that they choose to rewrite small pieces of the code also. Okay, so those are the things that tend to happen. But you never really, do this and end up with perfect design. Again, you're always working in the context of what you have. Now, the important thing about this, though, is that I think for this, it kind of requires a little bit of a change of aesthetics, our sense of what is good a little bit too. I love having code which is very nice and very good abstractions. I love having great design systems. But you also have to appreciate a bit the code which is maybe a little bit messed up, but you can make pieces of it better. It's almost like when you're working in the garden. It's kind of like that you can't make a garden completely perfect, but you can at least trim this bush. You can at least trim this tree and grow flowers over here and do these things. And you can appreciate what you have. Yeah.
Have you worked with legacy C#?
Legacy C# code? Yeah. It's a very funny thing about this. I have a friend I used to work with, and back when the Beta 2 stack for C# came out, I remember looking through this and reading it and everything, and I got a phone call from my friend, and he said, the strangest thing just happened. And I said, what? He said, well, somebody called up, and they said, well, we have all this legacy code that we want to go and need help with. And he said, well, what language is it in? And they said, C#. This is when the Beta 2 came out for C#. So it's kind of like, amazing. They had been writing all of this stuff in the beta, and they had all this crazy stuff. But no, it's true. I mean, you can have code which is messed up that was written 3 months ago. Just because C# is a relatively new language doesn't mean that you don't have projects that have design problems with it that are really hard to change. Is that getting at what you were trying to do? Do you think C#
Because C# has more features to override hard-coded behavior, like partial classes, when you can create additional methods without changing code or file.
But see, here's the thing. Right? To me, when languages have more features, that's a problem rather than a solution. The reason this is a funny thing because like partial classes, it's a good thing. But when you choose to adopt a partial class, it's kind of like, oh, now I see the word partial. I have to go someplace else and see what other secrets somebody has for somebody someplace else. When you kind of know that maybe the better thing is that you have the class all in one file, you're really going to basically really solve the problem. To give you another example, anybody remember aspect-oriented programming? Yeah, okay. So you can do some cool things with aspect-oriented programming. But in the beginning, one of the things that they said you could do with aspects is just go ahead and maintain code without actually touching it, right? You could say, oh, well, I want to add some before behavior to a particular method and some after behavior and go and add features in without really fixing the problem. And that's the thing we have to get back to with this, is that you know, you have to simplify. Fixing a problem often involves simplification. C# is a good language, but I do find it frustrating how we keep getting more and more features. And I think we're going to eventually get in that language to the point where we are in C++, where the amount of time it takes somebody to learn the language from scratch is very long because we have kept adding features. In my opinion, some of the best languages are ones that have a small set of features and you can use them well, and you don't have all this excess stuff. That's just an opinion. Yeah.
For what purposes do you use the ASP.NET program?
I don't really use it. No. I have some friends who use it periodically, but it's an interesting idea. You know the history of this, where aspects came from? Originally, this came from the Lisp community. Okay? No surprise. Okay, but there's essentially there was something called the Common Lisp Object System, which was an object-oriented system built on top of Lisp. And one of the people that was involved in this was Gregor Kixalis, who basically eventually created Aspect-J. And one of the things that he was interested in doing was he wanted to go and basically make metaprogramming available to people without calling it metaprogramming. What is metaprogramming? Well, it's like you have the class of your object and you can modify the class at runtime. And many of the things that you could do in Common Lisp Object System was go to an existing class and add behavior that would happen after the method or before, or replace the behavior. And my understanding is that he looked at this and he said, okay, how do we do this without having the concepts of metaclasses? Because metaclasses are going to scare people. The average programmer cannot handle metaclasses. So they basically invented an Aspect-J, a way of doing all these things through the concept of aspects. And then people have been trying to find, what is the best way to do this sort of thing. What I think is kind of interesting now is that you look at languages like Ruby, for instance, and you have average programmers working with metaclasses all the time now. We'll see how bad it gets. I don't know. You can't do crazy things with metaclasses. But this is a strange thing that's kind of happening in the industry now.
It's kind of magic.
Sorry?
It's kind of magic.
Kind of magic?
Magic. So you declare something and
Yeah. Well, this is happening in Rails. They do a lot of interesting natural things in Rails with Ruby, which is good. And I hope everything works out fine, but I know some people from the early Smalltalk communities, and they say that Smalltalk was great, but if you had one or two smart people on a team, you could really get in serious trouble because they would put so much magic in the code that when they left, nobody could basically recover the code base. And this is, sorry?
it's typical developer does not understand how this magic.
Yes, and the thing is, what's worse is because it's magic, you don't even see clues in the code base about where the magic happens, right? So it's like, using these magical features is good, but in a very disciplined way. And if you lose the discipline, then you end up getting in trouble. Another example of this, and again, it's from Lisp, is I've seen some blogs about this recently where the Lisp that comes with the Emacs editor, you can do many of these things that are kind of reflective magic within that to sort of change behavior. You've heard the term monkey patching in Ruby at all? Okay, the idea there is to just replace behavior on existing classes that come from the framework and just put in your own behavior. And in some communities, like the Lisp community, they've always had the ability to do this, but instead what they do is they really create real extension points where it's obvious that you can plug in behavior. You actually have a method you can use to plug in behavior. And they do this because, again, it makes things more explicit. And when things are more explicit, they become more maintainable. So, again, we're going to see what happens with some of these dynamic language communities. I hope things are okay, but we're probably going to be, over the next couple of years, dealing with a lot of code that it's going to be really, really hard to fix.
So which programming language is the best from that point of view?
Which is the program, as far as we cover?
Enough discipline to make it easier to maintain, or just not so bad?
I'm not really sure of this. I keep wondering what can be done to make programming languages easier to recover. And I think that this is a very important question for language designers. What do language designers think about when they design a programming language? Well, they think about what it takes to go make it easier to write code, easier to write correct code. But what they don't seem to think about is if people make mistakes, and these mistakes compound on themselves for a couple of years, how easy is it then to recover from those mistakes, to make things better? And I keep thinking about this, but I'm not really sure that there are a particular set of features that help that way. One could say that dynamic languages are nice because you can easily replace things and do all this mocking transparently. But also in dynamic languages you can make bigger messes too. It seems that any language which is powerful enough to do good working is powerful enough to make a mess of it. So, yeah, I'm not really sure. Any other questions?
Если у вас есть вопросы на русском языке, можете задать при translate.
Yeah. Okay. Thank you very much.